My final report is titled Solid Rocket Propellants, an Informative Comparison of Oxidizers. The purpose of my final report is to provide an informative comparison between the two most commonly used oxidizing agents in solid rocket propulsion systems. And the audience for my report is chemical engineering interns at Northrop Grumman. One quote states that ammonium perchlorate and ammonium nitrate are the most commonly used oxidizers applied in solid propellants. Therefore, these are the two oxidizing agents that I will be evaluating throughout my report. And just to provide some clarification, there are three types of propulsion systems and propellants that can be used, either solid rocket propulsion systems, liquid rocket propulsion systems, or gas. The desirable characteristics for a solid propellant are high specific impulse, predictable and reproducible burning rate, and ignition characteristics, high density, ease of manufacturing, low cost, and good aging characteristics. With these characteristics in mind and traits for a good solid propellant, I've decided to evaluate within my report efficiency of each oxidizing agent, cost, and the hazards that each of these present. To provide a little bit of background, Northrop Grumman specializes in products such as launch vehicles and propulsion systems, and they focus solely on solid rocket propulsion systems. This is a job posting for an engineering intern technician at Northrop Grumman. This was posted on April 7th of this year. And to kind of summarize, it states that interns work alongside engineers to design and develop solid rocket propulsion systems for global consumers. Some of these consumers include NASA and SpaceX. And the chemical engineering interns utilize their knowledge of oxidizing agents to manipulate and control the redox reaction between fuel and oxidizer. And my audience of chemical engineering students will be familiar with some of the terminology that I've used here, such as a redox reaction. This is essentially a reaction between a reducing agent and an oxidizing agent. The two primary sources that I used were scholarly articles and peer-reviewed journals. I used these heavily throughout my preliminary research, as well as to provide supporting evidence within my report. The cost for each oxidizing agent was evaluated using data from a study conducted by Purdue University students. This study provided a lot of comparative data and in chart form, which I've included within my report to help provide visual aid of the difference in cost. And this cost includes manufacturing, handling, and production of each oxidizing agent. Articles and information published by NASA and other reputable online libraries were also used to evaluate the cost. Efficiency was evaluated using technical documents and online articles regarding specific impulse, density, and burning rate. I chose these characteristics of the oxidizing agents to evaluate their efficiency because these are the most commonly used indicators of efficiency for an oxidizer. And specific impulse, the higher a specific impulse that an oxidizing agent provides, the more efficient it is. And for the burning rate, this is how fast the oxidizing agent and fuel mixture burns at a given pressure, and this also indicates a higher efficiency. The hazards were evaluated by researching the chemical reaction between ammonium perchlorate and fuel and the chemical reaction between ammonium nitrate and fuel. I also evaluated the emissions from each reaction, risks involved with manufacturing and handling, and then the lifespan of each mixture. This is important to know because sometimes some of these mixtures decay in a way that is hazardous, such as corrosion, explosion, etc. So my purpose changed after preliminary research was done and I had written a little bit of the draft. I changed my purpose because there was a disconnect between my audience and my purpose that I felt needed to be fixed. So I did thorough new preliminary research and conducted a new rough draft with this purpose. And then after the peer review feedback was given from the last rough draft. I did a lot of revision and editing to try to make my report flow better. Some of the findings that I found include that ammonium perchlorate presents a faster burn rate, and this is ideal for short duration motors. And then ammonium nitrate burns for a longer time, which is ideal for long burning motors. And this is going to be a specification provided by whichever consumer. There are different types of motors obviously used, and to be able to decide which oxidizing agent to use, the burn rate is pretty important. Ammonium perchlorate has a higher specific impulse, but only by a few seconds. This would mean that ammonium perchlorate is slightly more efficient, but not in a significant way. Ammonium nitrate presents less hazards because it is less reactive. The remaining work I have to do is my discussion and conclusion section. I still need to format my entire report to fit the guidelines and everything for the assignment. And then I also have editing and revision to finish. Like I said, I received a lot of really good feedback from my last rough draft. So that was really helpful. So if you have any advice, I've provided my email in case you want to send any suggestions or anything like that, but it's definitely appreciated. And then these are my works cited.